Assalamu alaikum everyone. Dear student, I hope you are fine and doing well. Today our lecture is about some question related to matrix of linear transformation that are quite important exercise questions. Uh, uh, how one can find some transformation with respect to standard basis or non-standard basis. Today who will focus on to answer such question related to matrix of linear transformation. I hope you will enjoy today's lecture. Let us start with some example. First example, we have some matrix of transformation like this one. If I can on this spotlight, here you can see this one. So uh, we have one matrix of transformation from R3 to R3 that take three tuples and map on three tuples. In that case, the matrix of transformation is of the order 3 by 3. So we can say this is one of the matrix of transformation. Find T in terms of coordinates uh, and its matrix with respect to bases V1, V2, and V3. So we need to calculate the matrix with respect to these bases. Since these V1, V2, V3 are bases, so it can be written any vector in here in this space can be written as a linear combination of this basis element. Because if you know the basis consists of linearly independent vectors and that linearly independent vector span basically the whole subspace or the complete vector space. In that case, in spanning this set of all possible linear combination of some vectors. So basis is basically consists of linearly independent vectors, and moreover these vectors span the whole vector space or any subspace. So first of all we need to find t in terms of coordinates. So in that case I means to say we need to calculate the from this matrix we have to calculate the linear transformation. And it is quite evident from our previous lectures that I talk about whenever we are talking about matrix, corresponding to every matrix, there is a linear transformation. And whenever we are talk about transformation, and there is always a uh, matrix corresponding to any transformation from Rn to Rm. So let us take one, say this is a coordinates from this R3. So I take T of x is a into x. Since this is a linear transformation, so I take a into x. So I multiply this matrix with x, then x is basically x1, x2, and x3. And I then just multiply, I will get 3 cross 1 column because my domain is range is also 3 cross 1 column vector. So if the first coordinate is x1 plus x2, second coordinate of this transformation is x1 minus x2 minus x1 minus s. So it can be written as a t of x1, x2, x3 is like this. First coordinate is written over here, the second coordinate is written over here, and the third coordinate is written over here. So we have solved this first part of this question, that find t in term of coordinates. In term of coordinate we calculate t. So t is in term of coordinate. No, we have to calculate the matrix corresponding to these bases. So as I told you, these are basis elements, so it can be written as a linear combination of uh, any element of this can be written as a linear. So I take T of V is equal to A V1 plus B V2 plus C V3. So T of 0, 1, 2 is basically I say uh, A, and then mm, I means to say V1, that is this one, B time V2, C time V3, then T of 0, 1, 2. I means I just put at here, I just 0 put over here 0, then 1 at x2 position and 2 at x3 position, and correspondingly putting all these input over here. So I get 3 minus 2 minus 1. and then we can solve this equation. I'll get x component as b plus c comma a plus b and 2a plus b minus 2c. In that case, if you can see over here, dear student, in that case, if you can compare x coordinate with x, y coordinate with y, and z coordinate with z, in that case we can get three equation in term of a, b, and c. Now, we just solve all these equation. This is first equation, this is second one, and this is third. We simultaneously solve these three equation and get a is equal to minus 11, b is equal to 9, and c is minus 6. And putting all these equation in equation 2, T of V1 is minus uh, 11 V2, then 9 V2 minus 6 V3. This is equation 2, right? This one. So in that case, similarly, we T of V2 can be written as A dash V1 plus B dash V2 plus C dash C3. In that case, we get V2 is 1, 1, 1. So I just put 1, 1, 1 in place of linear transformation. So I get the output is 2, 0, minus 2. In that case, similarly, I have solved these equation in a similar fashion as I solved in my previous slide, like over here. In that case, so dear student, in this case, I did the same step and comparing x coordinate with this, y coordinate with this, and z coordinate with this expression. In that case, dear student, I once again get equation in term of a dash, b dash, and c dash, and on solving these equations simultaneously for a dash, b dash, and c, we have a dash is minus 2, b dash is 2, and c dash is 0. Putting these equation in equation 4, I get t of v2 is minus 2v1 plus 2v2 and plus 0 v3. In similar fashion for as we have performed the above step for v3, we have t of v3 is 11 v1 plus 11 14 v1 plus minus 11 v2 plus 9 v3. Uh, the equation 3, 5, 6 give the matrix of transformation. If you can look over here, so the first, the coefficient of first equation like this one, this is minus 11, 9, and plus 9 and minus 6. In that case, minus 11, 9, minus 6, and coefficient of this equation, that is minus 2, 2, and 0, and the coefficient of this equation is 11, minus 14, minus 11, and 9. This is the basically matrix of a transformation with respect to basis v1, v2, and v3. Dear student, let us take another example. And why I am take this example? Because I'm going to show you in this example, it is not always necessary that you are always taking tuple transformation as a n input to n m output, or rn to rn. It is possible that you can take some any vector space of polynomial to some vector space of another polynomials. Like it can be like this transformation, that is the t take any polynomial, and this is equivalent to derivative of this transformation. I means to say t the transformation from set of polynomial to set of polynomial. So if I can find the matrix of transformation T with respect to basis, that's first basis of this P of X is, which is the polynomial of degree or not exceeding 3, together with 0 polynomial, that is it should not be greater than 3. In that case, the general polynomial of in this vector space of polynomial must be a naught plus a1 x plus a2 x square plus a3 x cube. In that case, the coefficient in case of polynomial whose degrees should not be greater than their coefficient are 4. So in that case, we have fundamentally 4 basis element in case of polynomial vector space of polynomial with degree not exceeding 3. So dear student, I just take these four polynomial in this equation. I have to find the matrix of transformation with respect to these four basis elements. Like in first case, the my first element of this uh, polynomial space is 1. So the transformation is not altogether from set of Rn to set of Rm. It is set from polynomial to polynomial. So the first element is t of 1 d by dx 1. The derivative of 1 is 0. So 0 into 1 plus 0 into x plus 0 into 2x squared plus 0 into 9x. Sorry, this is, it should be 8. It should not be 9. It should be 8. It should be 8. It should not be 9, because here, if you can look over here, uh, it should be, you just replace our 8. It should not be 9. So 0 time 1 plus 0 time x. So I write 0 in term of these as a linear combination of these basis element. 0 time 1 plus 0 time x plus 0 time 2x plus 0 time 9x. So t of x polynomial of degree 1, x, from here I take x, d by dx is, which is 1. So 1 can be there, 1 time 1 plus 0 time x plus 0 time, because this is a constant. So if you can look over here, so the first term is of the constant coefficient. So 1 into 1 plus 0 time x plus 0 time x square plus 0 time 8x cube. So it must be 8x cube. So two second component is 2x square. 2x square, the derivative of 2x is 4x. So 0 time 1 plus the, basically this is the coefficient of x. So 4 time x plus the coefficient of is x, 2x square is 0. So 0 time 2x square plus 0 into 8x cube. So t of 8x cube d by dx, this is 24x square. Here is some mistake, you can just correct it. This, it should be 24, I must correct it right now. So so this is hardcore, I cannot do it. So dear student, if you can look over here, you just correct it, it will 24x square. So 0 time 1 plus 0 time x plus 12 into 2x squared plus 0 into 9x cubed. If you can look over here, the coefficient of these are, the coefficient in this case 0, 0, 0, 0. So 0, 0, 0, 0. So the coefficient of here in the second term is 1, 0, 0, 0. 1, 0, 0, 0. So the coefficient of the basis element, these are in that case is 0, 4, 0, 0. 0, 4, 0, 0. So the coefficient in that case, dear student, please correct it. This is 24x square. So 0, 0, 12, 0. 0, 0, 12, 0. So in that case, the matrix of transformation with respect to these bases, that is, you have just first apply the transformation, then write this resultant as a linear combination of these basis elements. In that case, this will be the matrix of transformation. The second part, you have to solve it by, let us take the second part. The first basis element of second part is 2. So d by dx 2, it is 0. So 0 time 2 plus 0 time 2, 2 plus x, 0 time 2 plus x squared plus 0 time 2x, 2 plus x cube. So in second case, the second part of this base element 2 plus x. So if you can take the derivative, so 2 plus x is 1. So 1 by 1 into 1 plus, because this is the coefficient of this, because this is constant, so it must be the coefficient of constant. The first element of the basis is like 2. So the coefficient of in that case must be 1 over 2 in order to get 1 back, resultant as a 1. Plus 0 times 2 plus x plus 0 into 2 plus x square plus 0 plus 0 into 2 plus x cube. Rest of the step you have to solve it by your own. So in that case, dear student, if you can look over it, it must be 2 to the power 2 to the power x square. So in that case, if you just plug over here the coefficient, so 0 0 0 0, in that case the first column basically the is the coefficient of this linear combination, and the second column is the of this matrix is the basically the coefficient of this linear combination, and similarly third and fourth column are the uh, coefficient of this linear combination, and fourth column is the coefficient of this linear combination in that case. So these are the bases of t with respect to second basis that is given over here. So these are just. So let us take some short questions. Let T is a transformation from R square to R4. That is x and y are mapped on 2x minus 3y minus x minus 7y, comma x plus 2y plus 1, and then 5x minus 2. Whether this is a linear combination or not. If you can look over here, in a quite if you can look over here, so what it is, if you can just put just any element like 1 0, if you can say put x and y are 0 0 0. So if you can look over here, the it must be map on origin. If it does not map on origin, in that case it should not be linear transformation, because this is one of the property of linear transformation, that origin of this, that is origin of this is basically 0 0, must be mapped on origin of r square. Origin of r square I means to say 0 comma 0 comma 0 comma 0. So in that case, if you can look over here, so here the if I can put x is 0 and y is 0, the origin of this so this first term will be 0, second will also be 0, third will not be 0, because here we have 1. So fourth is 0. So 0 0 is map on 0 0 1 0. In that case, 0 is not map on 0. In that case, we must say here the transformation is not linear transformation. So you have to answer this question by your own, the second part. So let us take another example, that is a linear transformations from set of one-dimensional polynomial to set of two-dimensional polynomial, and it can be that is t of a plus b, that input is from linear polynomial and output is of second degree polynomial. Find kernel of transformation and range of transformation. First of all, you have to calculate the linear transformation by the given condition. The basis of in that case standard bases are 1 0 and 0 1. So you have to plug over here 0 1 and 1 0. In that case, dear student, if you can see over here, one is basically in that case coefficient of what I should say, the in that case the so there are some. So let us take, you have to take this as a like homework. Basically, this is not complete. You have just to solve it by your own. Uh, Basically, you have to solve this as a class work. So let me give you one another example, this is one of the matrix of transformation from Rn to Rn. Determine M and N and express T as a in term of coordinates. So if you can look over here, so matrix is of the order three rows and one, two, three, four, five column. So in that case, the three rows and five column, it means the n is five and m is three. So secondly, we have to express t in terms of coordinates. So t of x is into x, because this is a linear transformation. So I have to take t of x is equal to a into x. So my input is of belongs to R5 and my output is basically R3. So I take input as a x1, x2, x3, x4, and x5 five element in this column vector, and I just multiply it with the, since it is, sorry, let me correct it. Dear student, if you can look over here, it must be a into x, so it must be here you have to write it x. So if you can look over here, so if you can look over here, so in that case, dear student, we just multiply a with x, and x is input. So this matrix, which is of order three rows and five column, and this is five into one column vector. And if you can solve this one, so you will get three rows and three rows and one column. In that case, if you can see over here, three rows and one column, in that case, it can be written as in term of a double form, that is t of x1, x2, x3, and this is first coordinate of this linear transformation. This is second coordinate of this linear transformation. This is uh, third coordinate of this linear transformation. So ultimately, five input is map on three input vectors. So this is one of the today class about matrix of linear transformation. So dear student, I just uh, what I should say, example 3 is left as an exercise. So there are some hidden steps to solve this. So you have to solve this by your own. If you have any problem, do ask me. So in that case, the range of transformation I have just given it to you, but the how one can find the range of transformation, because there are some direct steps, so you have to solve it by your own. So in order to get all these steps and calculate the dimension and kernel of transformation in that case. Till then, dear student, Allah Hafiz, may Allah bless you all, and please stay at home. Allah Hafiz.